For more than 160 million years, Earth existed in a rare state of biological balance. Continents drifted slowly across the planet's surface. Oceans opened and closed, and climates shifted over immense spans of time. Yet life endured and adapted. Dinosaurs were not temporary rulers of this world. They were the architects of entire ecosystems, shaping forests, plains, and coastlines through their sheer presence. Vast coniferous woodlands stretched beneath warm skies, shallow seas flooded continental interiors, and complex food webs supported creatures of extraordinary size and diversity. This was a planet accustomed to patience. Even previous extinctions had unfolded gradually, allowing life to respond, migrate, and evolve. Earth had survived intense volcanism, rising seas, and shifting continents. Nothing in its deep history suggested that destruction could arrive suddenly, without warning. Above the atmosphere, beyond the reach of weather and seasons, the solar system followed its own ancient rhythms. Within that silent motion, governed only by gravity and time, a force capable of ending this age was already moving. Earth continued its rotation beneath the sun, unaware that the most abrupt transformation in its long history had already begun. Asterisk 66 million years ago, Earth was a greenhouse world shaped by warmth and abundance. There were no permanent ice caps at the poles, and global sea levels stood far higher than today, flooding vast continental interiors. Shallow inland seas divided land masses and supported rich marine ecosystems filled with plankton, ammonites, and large marine reptiles. On land, dense forests thrived under stable sunlight, and flowering plants were rapidly diversifying, forming new relationships with insects and herbivores. Dinosaurs occupied nearly every ecological niche, from towering herbivores that reshaped the landscape to predators that governed the balance of life. This planet was not fragile. It was productive, resilient, and deeply interconnected. Evolution had spent tens of millions of years refining these systems, slowly adapting life to predictable cycles of climate and energy. Every ecosystem relied on one constant above all others: the steady flow of sunlight that powered photosynthesis and sustained the food web from its roots upward. Earth had endured long periods of volcanic activity and gradual environmental change before, but its living systems were tuned to stability, not sudden disruption. The planet's greatest strength, its complexity, would soon become its greatest vulnerability. Long before Earth became a living world, the solar system was a violent place of collisions and creation. Planets formed from swirling disks of dust and rock, while countless fragments were left behind, drifting through space as asteroids. These objects were time capsules from the dawn of planetary history, unchanged for billions of years. One such fragment, more than 10 kilometers wide, followed a silent path beyond the orbit of Earth. It carried immense mass and velocity, storing an amount of energy far beyond human comprehension. For millions of years, its trajectory remained harmless, shaped only by gravity and chance encounters with other bodies. Slowly, subtle gravitational interactions altered its course. The asteroid's path bent inward, crossing Earth's orbit at precisely the wrong moment. There was no warning visible from the surface, no disturbance in the sky. When Earth's gravity finally captured the object, its fate was sealed. Space had delivered impacts before, but never one that would strike a planet so biologically rich and so unprepared. The forces that shaped worlds in the early solar system were about to return, colliding with a living Earth. On the final morning of the age of dinosaurs, Earth followed a rhythm that had remained unchanged for millions of years. Forests stirred beneath warm skies, rivers flowed into shallow seas, and animals moved through familiar territories, guided by instinct. Nothing in the landscape suggested that this day would be different from any other. Above the atmosphere, however, the planet was already under threat. The asteroid entered Earth's gravitational field and tore into the upper atmosphere, at more than 20 kilometers per second. Air in front of it was compressed so violently that it ignited, turning the sky into a blinding fireball brighter than the sun. In less than a minute, the object struck the shallow sea near what is now the Yucatan Peninsula, carving the Chicxulub crater deep into the planet's crust. The energy released was equivalent to billions of nuclear explosions detonated simultaneously. Bedrock was instantly vaporized. Ocean water was hurled into the sky. Shockwaves rippled through Earth's crust, triggering earthquakes across entire continents. In a matter of seconds, a planet shaped by gradual change was thrust into sudden, irreversible chaos. The moment of impact did not remain confined to a single region. Energy surged outward through the planet at unimaginable speed. Seismic waves raced through Earth's crust, destabilizing landscapes thousands of kilometers away. Forests collapsed as the ground convulsed beneath them. Mountains shed rock in massive landslides. Along nearby coastlines, the sea withdrew and returned in towering waves, scouring shores and flooding lowlands. Even continents far from the impact felt the tremors, as Earth responded as a single interconnected system under extreme stress. This was not merely destruction from above. It was a planetary reaction, the solid crust itself ringing like a struck bell. Animals that survived the initial shock faced a world that no longer behaved according to familiar rules. Rivers changed course. Coastal ecosystems vanished in minutes. The ground, once a stable foundation for life, had become unpredictable and hostile. Earth was no longer a passive stage for catastrophe. It had become an active participant, transferring the violence of impact across its entire surface and amplifying the scale of devastation beyond anything life had ever encountered. As the shockwaves faded, a second and even more devastating phase began to unfold above the planet. Trillions of tons of molten rock and pulverized debris were blasted high into the atmosphere, some reaching the edge of space before gravity pulled them back. For a brief moment, Earth appeared to have survived the worst. Then the sky turned lethal. As this material re-entered the atmosphere, friction heated it to incandescence, transforming the upper air into a global oven. Heat radiated downward with terrifying intensity. Within hours, vegetation ignited across entire continents. Forests, grasslands, and coastal plains burst into flame almost simultaneously. The night sky glowed red as firestorms spread beyond any natural boundary. Animals that had endured earthquakes and tsunamis now faced suffocating heat and smoke. Even regions thousands of kilometers from the impact were engulfed. This was not a series of isolated wildfires. It was planetary combustion, driven by physics alone. Earth's surface, once shaped by slow ecological processes, was suddenly subjected to temperatures capable of cooking life where it stood. The planet was burning, and there was nowhere left to flee. While fires consumed the surface of the planet, a quieter and far more enduring catastrophe was taking shape above the clouds. The impact had injected immense quantities of fine dust, ash, and sulfur-rich gases into the upper atmosphere. These particles spread rapidly around the globe, forming a dense veil that blocked incoming sunlight. Within days, daylight dimmed to twilight. Soon after, the sun disappeared almost entirely. Earth entered a darkness deeper than any volcanic winter it had ever known. Temperatures began to fall as solar energy no longer reached the surface. Photosynthesis collapsed on a planetary scale, shutting down the primary engine that sustained life. Plants withered and died, unable to produce energy. Herbivores soon followed, deprived of food, and predators were not far behind. The catastrophe shifted from explosive destruction to systemic failure. Ecosystems did not burn or collapse instantly. They starved. The planet was still intact, its oceans and continents unchanged in form, but its living systems had stopped functioning. Earth had not been destroyed, but it had been plunged into a prolonged night from which only the most resilient forms of life could hope to emerge. The oceans, which covered most of the planet, offered no sanctuary from the unfolding disaster. In the weeks following the impact, acid rain fell as sulfur compounds mixed with atmospheric moisture, altering the chemistry of surface waters. Sunlight, already blocked from the skies, could no longer penetrate the upper layers of the sea. Phytoplankton populations collapsed, removing the foundation of marine food chains that had supported life for hundreds of millions of years. Coral reefs died as temperatures fluctuated and acidity increased. Ammonites vanished, and large marine reptiles that once ruled the shallow seas disappeared entirely. Even the deep oceans, long considered stable refuges, were affected as nutrients stopped flowing and ecosystems starved. For millions of years, the seas had buffered Earth against environmental shocks, absorbing heat and sustaining life through gradual change. This time, the disruption was too sudden and too extreme. The oceans did not explode or burn, but they failed silently, transforming from engines of life into vast, dark expanses where survival became the exception rather than the rule. As months turned into years, the true scale of the catastrophe became undeniable. With sunlight blocked and ecosystems collapsing, Earth entered a prolonged state of global starvation. On land, forests that had once stretched for thousands of kilometers stood silent and dead. Herbivorous dinosaurs, dependent on constant vegetation, were among the first to disappear. Their absence rippled upward through the food web, sealing the fate of the predators that had ruled the land for millions of years. In the seas, the collapse of plankton removed the base of marine ecosystems, triggering cascading extinctions at every level. This was not a single moment of destruction, but a slow, relentless unraveling. Life did not end in fire or water alone. It faded through hunger and cold. Approximately 75% of all species vanished during this interval. Every non-avian dinosaur was lost, along with countless plants, insects, and marine organisms whose names would never be known. Evolutionary lineages tens of millions of years old ended without warning. Earth had endured mass extinctions before, but never one driven by such sudden and global environmental collapse. The planet remained intact, its mountains and oceans unchanged, yet its biosphere had been pushed to the edge of failure. Earth was alive, but barely functioning, yet life did not vanish entirely. In the long darkness that followed, survival favored not strength or size, but flexibility. Small mammals, birds, reptiles, and hardy plants endured conditions that overwhelmed the giants. Creatures that required less food, that could shelter underground, hide in water, or enter states of dormancy, gained a crucial advantage. Seeds lay dormant in the soil, waiting for light to return. Insects survived in protected niches. Mammals that fed on carrion, insects, or stored food endured where specialized herbivores could not. The world had grown quieter. The thunder of massive bodies moving across the land was gone, replaced by subtle movements in the shadows. Ecosystems were reduced to fragments, but those fragments persisted. Over years and decades, these survivors spread cautiously into empty spaces left behind by extinction. The age of dominance had changed hands, not through conquest, but through endurance. In the absence of the giants, evolution began to experiment again, setting the stage for a planet very different from the one that had burned. Gradually, the veil in the sky began to thin. Fine dust settled back to the surface, and sunlight returned in weak, uneven pulses. Temperatures stabilized, ending the long grip of impact winter. The first signs of recovery appeared quietly. Hardy plants sprouted in scorched soils, followed by insects that fed on decay. These small changes marked the reawakening of photosynthesis, restoring the foundation of food webs that had collapsed years earlier. Rivers once choked with ash began to clear. In the oceans, plankton slowly returned, allowing marine ecosystems to rebuild from their most basic levels. Recovery was not fast, and it was not uniform. Many regions remained barren for centuries. Yet life persisted, adapting to a world that no longer belonged to giants. The landscapes that emerged were simpler, shaped by smaller organisms and shorter food chains. Evolution moved cautiously, filling empty niches one step at a time. Earth had survived its darkest night. What followed was not a return to the past, but the slow construction of a new biological order, guided by chance, resilience, and time. With the great predators gone, and the land reshaped by extinction, mammals began a transformation that would redefine the planet. For tens of millions of years, they had lived in the shadows of dinosaurs, small, nocturnal, and constrained to the margins of ecosystems. Now those constraints vanished. Empty niches stretched across continents. Mammals diversified in size, form, and behavior, adapting to forests, open plains, rivers, and coastlines. Some returned to the trees, others took to the ground, and a few moved back into the sea. This expansion was not explosive, but it was relentless. Evolution favored adaptability, intelligence, and social behavior. Over millions of years, mammals grew larger, more complex, and more specialized. Primates emerged in forest canopies, developing grasping hands and forward-facing eyes. These changes were subtle at first, unfolding over deep time, yet their consequences were profound. The catastrophe that had nearly ended life on Earth had cleared the path for a lineage that would one day study the planet's past and uncover the evidence of this ancient disaster. The age that followed belonged not to giants of strength, but to survivors shaped by flexibility and resilience. Long after forests regrew and animals reclaimed the land, the mark of the catastrophe remained etched into the planet itself. Beneath layers of sediment and seawater, the vast crater left by the impact endured as a permanent wound in Earth's crust. Shocked quartz, melted rock, and a thin global layer rich in iridium became silent witnesses to the moment when the sky fell. These geological signatures were scattered across continents, preserved in stone far from the site of impact. They told a story that life alone could not remember. For millions of years, the scar lay hidden, buried by time, while Earth continued to change above it. Mountains rose and eroded. Oceans opened and closed. Life evolved without awareness of the event that had nearly erased it. Yet the planet never truly healed. Deep within its structure, the evidence remained, waiting to be uncovered. This was not merely a local feature, but a planetary record, a line drawn across deep time, marking the boundary between two worlds. The Earth that existed before the impact was gone forever. In its place stood a planet reshaped by chance, carrying the memory of near extinction within its very bones. The asteroid impact marked one of the sharpest turning points in the long history of life on Earth. Before that day, evolution had been shaped primarily by slow forces: climate shifts, continental drift, and gradual competition between species. After it, the rules had changed. Chance and catastrophe had rewritten the trajectory of the biosphere. Entire evolutionary paths were erased, not because they had failed, but because they had been unlucky. In the emptiness left behind, new possibilities emerged. Ecosystems rebuilt themselves along different lines, favoring smaller, more adaptable organisms. The structure of life became more dynamic, more experimental. This was not progress driven by purpose, but by survival. The planet had come closer to biological collapse than at any other known moment. Yet from that brink arose a new balance. Over tens of millions of years, the consequences of that single day continued to unfold, shaping climates, landscapes, and lineages. The Earth that followed was not stronger or weaker than before, but fundamentally altered. Deep time had been divided into a before and an after, separated by a thin layer of stone that recorded the moment when the planet almost lost its living world. Earth almost died that day. It was crushed by impact, scorched by global fire, and silenced beneath a sky without sunlight. For years, the planet's living systems faltered on the edge of collapse, and the age of giants ended not with a slow decline, but with sudden finality. Yet Earth endured. In the darkness, survivors carried life forward, small, adaptable organisms that could wait, hide, and persist until the world became habitable again. When light finally returned, it did not reveal the old Cretaceous world. It revealed a planet transformed, stripped of its rulers, and open to new forms of life. Over millions of years, recovery became expansion. Mammals diversified, forests reshaped, and ecosystems rebuilt themselves into something unfamiliar. The scar of the impact remained buried beneath rock and sea, but its legacy spread across every habitat on the planet. The catastrophe that nearly erased life also cleared the path for a future that would eventually include creatures capable of remembering it. This was not the end of the world. It was the moment the world became something else, and the first chapter in the long, fragile story of how Earth keeps surviving its own history.